So, hello. I hope you're enjoying Helsinki. It's cool. But I'm not, even though I live here, I'm not originally Finnish. I'm Fabrizio, and I come from Italy. And, you know, as you might have guessed, noticed on the internet, Italians do really care a lot about food. Yeah. I don't know if you see this, but it's great. So anyways, what happens when you put all of these people to study computer science? That's right, they want to fix computer science with food. So that's why I'm here to talk about Dhall. Dhall. Oh, man. Dhall. Right. Dhall is a great Indian dish. If you've never tried, I would really recommend that. It's not strictly Italian, right? But, you know, modern science is like all over the world, so we accept contributions from all over the world. This is good. And you might be wondering, like, is this a joke? Like, is this another monad tutorial? Are you going to tell us that monads are like a soup? Like, what? No? Like, of course, a monad is like a taco. But anyways, oh, this is not really working well. Sorry for that. Yeah. Yeah, let's start from the beginning. I work at KSF Media here in Helsinki. We have an amazing team. I'm really happy. And we're hiring, so if you're interested in that, just come talk to me later. And what I do there is that I'm a full-stack developer. Who's a full-stack developer here? Yeah, right. So, you know, like we do all of these things. Front-end development, back-end development, and this thing called DevOps. So what is DevOps? Well, DevOps is fun, or it's like developers brave enough to do ops. I find this quite fitting, but this is also true. Like, it's like having a REPL, but you spend 5 minutes after I press enter. But yeah, like, why am I here, right? DevOps is kind of hard sometimes, so we might need some Lambda superpowers. Not this many, like we don't need the whole Lambda, man. Like just a bit, just a bit. Yeah, so what do DevOps do in reality? We write code, like files, configurations, things, and we make like huge side effects, like I'm spawning cluster or so machine in Frankfurt, or like I'm deploying a bunch of databases in Ireland, all of these things. They're supposed to be good things, but sometimes bad things happen. It's good, right? But there is a bunch of problems with DevOps. Why is it hard? There is problems, of course. When you write the aforementioned code, right, there, it is most likely impure. Because, I mean, you just put a bunch of bash scripts together, or like Python. It's like stuff might be bad. And why is this important? I mean, I don't even have to convince you that impure code is bad, because this is a functional programming conference, so I'm not going to spend time on this. But yeah, of course, our goal is to have replicable infrastructure. Why is this important? Well, you know, if you think about infrastructure like this, when these tires catch fire, well, we want to replicate this situation. This slide is from the awesome talk of Kyle Kingsbury, Anna Concurenina. If you didn't watch that, I really recommend watching it. And another problem is that, like, configuring things is not a solved problem. Like, well, maybe it was like, I don't know, 30 years ago. Now we have way too many langs, and like these configurations are mostly data, so like sometimes it's tedious, it's hard to configure, all of this. But to illustrate this, I'm gonna tell you a story of like how we ported our deployments to the cloud. Still going on. We wanted a replicable setup, right? So we started with Terraform. If you don't know about Terraform, it's a tool in which you write like a declarative configuration, and then it will just spawn the things for you. You don't need to worry about like keeping the state. It will do the thing for you. You say, hey, I want this here with these parameters, and you just say, hey, Terraform, deploy this for me. And it works. But you have to write this funny language that they invented, HCL. Yeah. And then we deploy a Kubernetes cluster on that. Kubernetes is container orchestration. I'm going to get back to that later. So for configuring that, you need to write a bunch of YAML. Fine, let's write some YAML. But then you might need to some templating. Like, I want to configure my environments. Like, OK, we have stuff in staging, stuff in production. I want them to have some different parameters and so on. So I'm just going to use a templating language. Jinja is good. I'm going to use that. And then, of course, to orchestrate Jinja, I'm going to throw in some Python, because I need to configure some additional things. This is all good and fine. Let's do that. And then, to configure that, I need to write some YAML. Like, when I came to this realization, I felt a bit like this, like, Ouroboros language. If you didn't see this, like, there's a Ruby program that generates a Rust program that generates a Scala, and so on for 128 languages. I felt a bit like that. Yeah, so you might be wondering, hey, wait a sec. You're here on the stage to tell us that this is about templating configurations. Yeah! Like, this is, oh, sure, sorry. This is bad. And like, you might say, hey, go home. I mean, but there is 25 solutions already. We just pick one. But that's a problem. Like, what if we could use one? I know, right? Like, this is what every vendor says every time. But, like, bear with me. So yeah, there is like a bunch of solutions that are almost there. Like, it's almost right. Ansible, Nix, Terraform, they all fine, but there is something like not good, which doesn't make them like viable in the long term. But I'm not going to spend time on this. And if you're interested, let's just talk later. But yeah, what's my main issue with this? Like, it's climbing the abstraction ladder, which is, OK, I have some data, and then I want a bit more features. Like, I want an if. I want to like make this a bit more parametric. Like the whole thing, like I want things configurable and modular and composable and like so on, because it is useful and saves times and all of this. And like, yeah, you might be like, OK, just pick the most powerful tool you could possibly have. Take Haskell, use a library that you cannot go wrong, like go with the maximum power. But you don't need all of this. If you're not writing an operating system, you don't need all of this. You can like get along with much less, and this saves you in complexity. But I'm gonna like illustrate this with a graph. So data is code, code is data, all of that thing. You have data here with like the minimum abstraction power, and then you have code, which is like Turing-complete. You can abstract all of this thing. Yeah, there is a clear line here, which is like the Turing-completeness border. Like, stuff after that is like full-blown Turing machines. And why is this a thing? Because, well, this doesn't work, right? Because this is dangerous. Like, there is security dangers. You can build too much abstraction. Your programs might not terminate. They might accept all of these things. So if it's possible, we can stay here. And it is kind of possible, if only this thing would work. Right. And yes, there is this thing called Dhall that stays just right here. I'm going to tell you later about this. But in general, in this area, there is all of these strong normalizing languages and total languages. Strong normalizing means that you have a language in which every term always normalizes to a normal form, which is not reducible, so you cannot have recursion. Or in total languages are languages for which, for every input, all outputs are defined. Not going to spend time on this, but so if you're interested, just let's talk later. But I just recommend reading this paper, Total Functional Programming by Turner. Who has read that? That's cool. Please read that. It's really cool. But yeah, it's speech time. I mean, you're here on the stage since 2 hours trying to convince us of something. Just say that already. That's right. So I'm going to present this Dhall in like 30 seconds. Let me check. OK, that's right. Ready? So yeah, Dhall is a great Indian dish. It's also a character of a video game. But most importantly, yeah, it's a language. A project was started in 2016 by Gabriel Gonzalez. He makes great stuff. And it's basically a JSON in which, like, picture this. It's JSON. But you have functions. And then it's typed. And then you can import stuff. So like, it's kind of modular, right? And this is cool stuff. How do you install it? You can just download static binaries from GitHub. If you have Stack, you install it with Stack. If you have Nix, install it with Nix. There is Debian and RPM packages in the works. So let's take a look at the primitives of this. If you install that, you get a repo. So I can start up a repo. And you have the usual stuff. You can add numbers. And then you have comments, which is a great improvement over JSON already. And then, well, you can ask the types to the repo. So these are natural. You have also integers, but most of the operations are defined on natural. And then you have lists. So that's right, we can concatenate lists. And then you have records or maps or dictionaries, and they're typed. So here we also have text. And then you can merge records. If you have two records, you can just merge them, and the right record takes precedence. There is also a different merge operator. But yeah. And then you have optionals, and they have the same syntax as in Rust or Scala. And yeah, if you have an optional with a value, you have the value there. If it's empty, you just put the type there. And this is not out yet, just got merged, so it's not released. Currently, the optionals have another syntax, so yeah. And then since this is an actual programming language, you have if and else, and it works only in Booleans, though. And then you can define names with let. So here we define the name, and then a string, and there is string interpolation. So I put just the variable name in there with the usual syntax, and then we can just print the string. And yes, it has UTF-8 support. And then you have the function. So you define the function in the same way as Haskell. You specify the type there, and then there's the arrow, and then the body of the function. And here I'm asking the type of the function. It's from natural to natural. All good. We can assign the function to a name, and then just apply that there. Then we get the number back. And then, as I mentioned, there is imports. So let's assume that I put the previous cube function here. I just paste this function into a file, and I call it cube.dhall. Then I can just import that here. And as you see, I can also import stuff from the internet. Like here, we're just importing the map, the list map from GitHub. And I mean, this is insecure, right? But as you see this SHA here, it's a hash of the import. So for every import, you can put just the hash there. And if that import ever changes, Dhall will refuse to execute your program. So this is safe. So what we do here, we import the map from the prelude. We import our cube function, and then we just map the cube function over a list, and we get a list back. I know, right? This is really bad. But as I mentioned, this has been thought about. So there is import hashing, and in the language standard, there is a definition for import chaining, and you can do some things, and you can not do some things. For example, if you have an import from the internet, and that import imports something relative to itself, well, that cannot import other domains. But all of these things are defined in this, let's say, wiki page on the Dhall wiki. So if you have any concerns, just look at that, and everything is explained there. And all the attack vectors are taken care of. All good. So we have the primitives. It did not take quite 30 seconds. Sorry for that. But we can build some abstraction over this. So there is the standard library on GitHub. Let's take a look at that. Right. So yeah, it's over here in GitHub. And here we can see the map. There is nice documentation for all the standard library functions, and here the definition of the map is just a list build with a bunch of function applied. Yeah. So, right, I'm 2 hours here and didn't talk about DevOps even if it was in the title. That's right. Yeah. So to explain a bit this abstraction, I'm going to talk actually about how to apply this to DevOps and generating configs. So there is a problem to solve before we get to that, and most of the tools don't actually eat Dhall. So how do we fix that? Well, some tools have been built to take care of that. So you can output Dhall to text, to JSON, YAML, Cabal, Nix, all the things. I mean, we use that to output SQL. So it's good. And yeah, you can definitely do DevOps with Dhall. And we made this thing called Dhall Kubernetes, which is basically a layer on top of Kubernetes. And let's define Kubernetes for a sec. So who knows what Kubernetes here is? That's really good. But for the rest, so Kubernetes is container orchestration. So you make a Docker container, and then you install Kubernetes over a bunch of machines. And then you just give the container to Kubernetes, and Kubernetes will take care of things like scaling, routing, rolling deployments, all of the things. You just give it a deployment, a container, and everything will be fixed. All good. So what's the problem with Kubernetes? Well, it's somewhat verbose, and YAML is not that flexible. So this is the basic example for deploying an Nginx web server. It's kind of long. I just wanted an Nginx. Yeah. So to fix that, we took the OpenAPI spec from the Kubernetes repo, generated a bunch of Dhall types from that, and then built a small API on top. And then our happy DevOps just takes that API and configures the deployments. So let's see how that looks. So yeah, the Dhall Kubernetes repo is over here on GitHub. And so let's say we want to deploy an Nginx web server on our kube cluster. So I have a Kubernetes cluster on my machine. Oh, well. Right? It's running, and oh. Yep. So let's say that we want to deploy this Nginx, and we have the configuration for the Nginx just here. So what we want to do is that we define how our Nginx is going to be configured. So there's the name for the deployment, how many replicas we want, and the containers that we're supposed to deploy. Here's the Docker image and the image tag, and the port on which is going to be exposed. And then we just merge our information with the default that we specify there with the merge operator over there. And then after this, we just import this make deployment function, and then we apply it to our config. Not really Italian-friendly stage. Sorry for that. But anyways, so let's execute this to generate the Kubernetes configuration. So Dhall to YAML. So in here, we just take our file that I just cut, and then we just pipe it into Dhall to YAML. We omit the null, and then we pipe it back to the deployment YAML. And how all of this looks is that, so in here, there is the type of the deployment. This is automatically generated from the Kubernetes APIs. And then here's what we actually want to generate, which is this big YAML. And it's Nginx deployment, but it is production ready, unlike the example you find on the internet. And this is all of the make deployment function that we import. This is doing a bunch of things that just take your nice looking configuration and generate the monstrosity that Kubernetes wants. So it's a bunch of functions and some folds and so on. You can take a look at that. But anyways, so yes, this is done now. We can cut our deployment over here, right? It looks like the thing that we wanted to generate. You can see there in the containers, that's our Nginx with the tag and so on and so on. So let's now pipe that to Kubernetes. So, right? We pipe the deployment to Kubernetes, and the Kubernetes says, I created that. So let's see about that. So we ask Kubernetes for the pods, and the Nginx server is running already. So now we expose. So now we expose the Kubernetes deployment to the outside, so we can curl it from this machine. And then we ask curl to gently get us the Nginx. And yes, here you see the Nginx homepage. All is good. Stuff is deployed. Side effects happen. All good. So yeah, there is a bunch of links to the things I just shown. But that's it. So I have a bunch of take-home points for you. Do DevOps, it's good. Kubernetes is good. YAML is not good. So if you're doing YAML, consider this seriously. And limit your abstraction power. Like, you don't need to overcomplicate yourself with like a lot of abstraction that then you don't understand anymore, and like then you have the problem, oh, I wrote my configurations with a programming language, now I need to refactor them, but now it's too abstract, oh my. So that's a real problem. So yeah, write total programs. Like this is good. You can always normalize this stuff to a normal form, so it doesn't get like overly complicated. And yeah, last but not least, eat good food. Yep, thank you. Questions?
Yeah, I think we started a bit late, so 2 questions. One's from...
So I'm curious how, by what I'm seeing of what Dhall is capable of, how are you preventing it from being Turing complete? Because you have presumably recursion if you can do a map over a list, and you have conditionals, which is really all you need. I mean, brainfuck does everything with pretty much just less than that. So exactly, I guess I'm not clear on how it actually prevents that.
So a map over a list is a fold, and that always terminates.
So essentially you're confining what functions are available rather than...
That's right. Like you cannot call a function inside yourself. So you don't have recursion in functions, and then you only have folds to transform your data structures.
Oh, okay. Yeah. That makes sense.
Cool.
Any more?
Thanks, great talk. Here in the example, you converted one configuration to another configuration.
That's right.
What if you have a tool that doesn't have like a configuration, but you want to turn it into imperative instructions or commands? Can you do that with Dhall? What kind of adapter would need to build?
Definitely. You just need to write a bunch of Dhall code. As Oleg says, it's more engineering. Yeah, like of course you can, like, if you can figure a mapping from like whatever format you have to other format, that's okay. Yeah. Did I answer the question? Cool. Let's talk about that. Any questions? Are we out of time? There's a question.
Where?
I mean, let's take that.
Keep it short.
Like, I'm really happy that you seem to be bringing kind of back the piece of Unix folklore that always when you have a configuration format, you run a macro processor on that before. So is it a kind of, do you see Dhall as a kind of very secure macro processor for configuration files?
That's basically what it is.
Yeah.
Yeah, definitely.
So Unix is coming back.
I hope so.
Okay, thank you.
Was it short enough?
Yeah, that was really short.
I have a last let's say, recommendation. Thanks. Today I just released this Dhall closure, since this is a closure conference, right? And this is a compiler from Dhall to closure. So you can now use your Dhall configurations, which are typed and like always terminate in your closure programs. Actually, Dhall is more than that. Like, I have this dream that we could use that as a binary representation and just throw it around the wire. But yeah, how you do this is just like, you just have a string with your Dhall and you just input that. And then we just execute the Dhall and give you back the closure structures. So here I just like evaluate an end, but here I'm evaluating a function that returns a record, and then I can just like execute this function in closure, and then I get back a result. So that's it.
Thank you, Fabrizio.
Thank you.